There you go.
Tony, can you please just tell us about the GPU compute that you have back here?
Sure. So we're masters of graphics, and that uses a GPU. A GPU is in fact a parallel processor. And parallel processing is something talked in the computing world for decades. Now it's mainstream high volume. Because of the graphics, which you need for user interfaces, for gaming, all those great things. The thing is, it's a very powerful processor. So GPU compute is about taking advantage of all the power in that graphics processor and using it for other things. And we think this is arguably even more exciting than some of the things we're doing in graphics. And here's a few examples. This is working with a partner called Vidaro. They're doing smart cameras for retail analytics. And so you'll see above, we've got what was called a time of flight camera. And that is actually looking down on us and measuring our movement. And what this is doing is working on this analytics here. You can see it's tracking everybody in the scene. It's emulating a store, so the red line here is the boundaries of the store. It's counting people coming into the store, people that leave the store. And this is meant to be the sort of register area, and these are queues. And this is all about gathering data, details of how people behave in a store. In order to get better quality, how to organize the store, how to make a store more effective, a better user experience. And this is what this is all about. It's all about how to make a bricks and mortar retail experience much more exciting, much better for the customers. This sort of system is usually complemented by face mounting cameras that will be detecting you, analyzing your movement, seeing how you behave. That's generating a lot of data which the retailers themselves want to use to organize their store, and the people selling goods in the store want to know to understand how are people interacting when they see their product on the shelves. And so this is spawning a whole new generation of highly intelligent stores. For the user, we should get better deals. We should have deals targeting us because it will know what we want. The retailers will do a better job of making the store easier, more exciting for us to use, and the products will be better because they'll respond to what we want to know about than what they think. So this is a part of a sea change in the future of retail, a very, very important part of keeping physical stores alive. And we think that that's very important. We don't want everything to go online. This GPU compute is in the camera because this has to be done real time, instantly. And so you can't afford to send it to the cloud and analyze it, so therefore everything is very intelligent, and we're using the GPU in every camera to be able to do this. There's a lot more you can do with the GPU with a camera. Here's a simple example here. We're in a standard tablet using our GPU and using the GPU in this case to do a fisheye lens. So we're actually generating a lens totally in software. And so this effect, what we're using is a technology called zero copy. This means that you can see there's virtually no delay between what the camera is seeing and this highly processed image. And that's because we have special technology, because we've designed every aspect of the system so that we can move data very, very quickly from start to finish in the processing. And this GPU compute is an example of the imaging platform that we announced today, which is a complete set of reference tools and software frameworks that enable people to implement applications like this very quickly and get them to production. So this is a whole new way in which people are using existing chips with our GPUs to get new value-added features. And we've got a number of OEMs very excited about doing this sort of thing. Another example of this, and again this feeds back into the retail analytics, is this application where the same GPU can also be doing face detection. And from here it can be doing face recognition, gender classification, all sorts of things. And all of these are tasks the GPU can do. And this is making the GPU an incredibly powerful part of software for the next generation of advanced features.
This has a lot of security applications too, right?
Absolutely. So security is a big part of a lot of the technology we do. In our MIPS processors, security from the very low end to the high end is a very, very strong part of what we're doing. And so security in IoT is something we don't think people have taken paid sufficient attention to. So yes, security in terms of cameras being able to recognize and detect events, whether domestically or commercially, is important, but also securing private information. There's a lot of information in from multiple sources, so you need what's called multi-domain security. Our MIPS processors implement that not only in the high-end processors and mainstream processors for Android and Linux and so on, but all the way down to our lowest-end embedded processors down into each individual sensor. And that means we can make highly secure systems for every aspect of an IoT-based application.
I mean, I imagine there's a room in the Bellagio with a monitor bank that looks something like that, right?
Yeah, and the problem with those big monitor banks is it requires somebody to look at all of them to figure out what's going on. This technology will enable you to put many more cameras and actually make them spot the guys doing the problem at the time rather than the lottery of whether somebody happens to be looking at it.
That's amazing.